Before we begin talking about linear programming and what that application is, we first want to consider some examples of how we graph systems of inequalities with Desmos. There's a little bit of a trick to this, but once we get the hang of it, it's really not too challenging. We just need to learn a little bit of specific notation for Desmos. We'll start with example 1, where we have these two different inequality statements, one of which is a strict inequality. So flipping over to Desmos, the first thing we'll do is enter both of these inequalities and just convert them to equations. So we'll drop that inequality portion altogether so that we have our two lines graphed and we essentially have our boundaries determined. We should know from here that we're going to shade one of these four regions. And the other thing that we can do is adjust our second line to be a dashed line since it has that strict inequality. So we're graphing one solid line and one dashed line. And now what we'll do is type in one of those inequality statements, which will begin to shade, in this case, below that line. But what we want to do is only look at shading the final region for this graph. We could look at including that second graph, which we would see all of the shaded regions and we would look for that area of overlap. But that can get a little confusing, especially in our later examples where we're going to be looking at more than just two lines or more than two inequality statements. So what we'll do is delete that second inequality and, graphing just this first one, include essentially a restriction on that graph by inserting these curly braces. And the restriction that we'll insert is that 2x plus y has to be greater than -6. So by including that first inequality statement and then any remaining statements as restrictions on that first inequality statement, what we get is simply the final shaded region that represents the graph of this solution of linear systems. Now what we can do is apply this same idea in example 2. Here we have four different inequality statements. So deleting what we've got, we'll again graph each of these as a straight line. Graph each of these as just a line where we replace the inequality statement with just an equation or an equal sign. What this does, again, is gives us all of our boundary lines. And then to identify the shaded region that corresponds, we would start with any one of those inequality statements, and then in a set of curly braces, we'll include the next inequality statement, and then continue to do that for each of the remaining statements. So as we continue to apply these different restrictions, Desmos continues to change the region that's being shaded to give us, in this case, this unbounded shaded region that represents that system of inequality statements. In example 3, we have a very similar system. All that's changing is the direction of our inequality statements, as well as one of the numbers on the right-hand side. So we can look at simply updating our statements here to be 3x plus y now is equal to 6. X plus y is now less than or equal to 3. And 3x plus y is going to be less than or equal to 6. And what that does is, again, gives us our shaded region, which is the graph of that system of inequalities. And in this case, we end up with this bounded region. This process of including all of these statements as restrictions on one of those inequalities just allows us to avoid having to determine where the region of overlap is, which would start to become a little cumbersome once we have four more different inequalities being graphed. And again, just lets Desmos do the work for us to identify what that final bounded region should be.